Problems on calorimetry. In calorimetry, two types of questions generally asked in the examination. One is your mixture, another type of question is the change of phase. When 0.15 kg of ice at 0 degree centigrade mixed with 0.30 kg of water at 50 degree centigrade in a container, the resulting temperature is 6.7 degree centigrade. You have to calculate the heat of fusion of ice, and it is given the specific heat of water is 4186 joule per kg Kelvin. So in the question, mass of the ice is given 0.15 kg, and we know ice is at 0 degree centigrade, and the ice is mixed with water which is at 50 degree centigrade, and the mass of water it is given 0.30 kg. So first the ice will melt from 0 degree centigrade to water at 0 degree centigrade. Then the water at 0 degree centigrade will mix with the water at 50 degree centigrade. So heat will be lost by water and heat will be gained by the ice or ice water. So the formula used in calorimetry is heat loss is equal to heat gain. So you calculate the amount of heat lost by water and the amount of heat gained by the ice. Then from equation heat lost equal to heat gain, you can calculate the latent heat of fusion. So what is the heat lost by water? For heat loss by water, you have to use the formula Q equal to ms theta or Q equal to ms theta 2 minus theta 1, because here there is no phase change. If there is no phase change, only there is change in temperature in one state or in one phase, you use the formula Q equal to ms theta 2 minus theta 1. Here mw is the mass of water, sw is the specific heat of water, and the temperature of water it is given 50 and final temperature is 6.7 degree centigrade. So if you put these values, then you can find out the heat lost by water is equal to 4376.4 joule. Now we will calculate the heat gained by ice. Heat gained by ice can be calculated like this. First, ice will be melted to ice water. That is, you have to use the formula Q is equal to ml, because in phase change there is no change in temperature, and use the formula Q equal to ml. Here mi is the mass of ice and L is the LF, that is the latent heat of fusion of ice, plus you have to again use this equation ms theta 2 minus theta 1, because ice first ice at 0 degree centigrade will be converted into water at 0 degree centigrade in phase change. Then there will be change of temperature. During change of temperature from 0 degree centigrade water to 6.7 degree centigrade water, you use the formula ms theta 2 minus theta 1. Here mi is the mass of ice and sw is the specific heat of water, and theta 2 is your 6.7 temperature of the mixture, and theta 1 is equal to 0. So if you put these values, then you can find out the latent heat of fusion of ice is equal to 3.34 into 10 to the power 5 joule per kg, which is very close to the experimental value. Now we will discuss another important problem in calorimetry. Calculate the heat required to convert 3 kg of ice at minus 12 degree centigrade kept in a calorimeter to steam at 100 degree centigrade at atmospheric pressure, and given specific heat of ice is 2100 joule per kg Kelvin. Specific heat capacity of water is 4186 joule per kg Kelvin. and latent heat of fusion of ice is 3.35 into 10 to the 5 joule per kg, and latent heat of steam is equal to 2.256 into 10 to the 6 joule per kg. These are experimental values, and they are known values. So in this problem, it is given that 3 kg of ice at minus 12 degree centigrade will be converted into steam at 100 degree centigrade. So first there will be change of phase. During change of phase, there is change in temperature in ice. Ice is at minus 12 degree centigrade. So first ice will be converted into 0 degree centigrade. Okay. First there will be change in phase from change in state of ice from minus 12 degree centigrade to 0 degree centigrade. Ice at 0 degree centigrade. Then ice at 0 degree centigrade will be converted to water at 0 degree centigrade. This is the phase change. Then there will be change of temperature from water at 0 degree centigrade to water at 100 degree centigrade. Then there will be phase change, that is water at 100 degree centigrade will be converted into steam at 100 degree centigrade. So here you have one phase change, here you have another phase change. So there are two phase changes here. So when ice at minus 12 degree centigrade will be converted into ice at 0 degree centigrade, use the formula Q equal to ms theta. Here m is the mass of ice, that is 3 kg, and s is the specific heat of ice, it is given, and difference in temperature theta 2 is 0 and theta 1 is minus 12. So if you compute the values, given values, even you can find out the amount of heat is equal to 75600 joule. Now ice at 0 degree centigrade will be converted into water at 0 degree centigrade. So here there is change of phase. In change of phase you use the formula Q is equal to ml, and mass of ice is given 3 kg, and latent heat of latent heat of fusion of ice, it is given 3.35 into 10 to the 5 joule per kg. So amount of heat released during this phase change is equal to Q2, that is equal to 1005000 joule. Then water at 0 degree centigrade will be converted into water at 100 degree centigrade, and this is there is change in temperature, and during change in temperature you use the formula Q is equal to ms theta. Here m is the mass of water given 3 kg, and SW here is the specific heat of water, it is given 4186, and the difference in temperature, that is 100, final temperature 100, initial 0, so 100 minus 0. So if you compute these values, then Q3 will be equal to 1255800 joule. Then there will be phase change, that means water at 100 degree centigrade will be converted into steam at 100 degree centigrade. So here you use the formula Q is equal to ml. So using the formula Q is equal to ml, here m is the mass of water and L is the specific heat of latent heat of steam. So the latent heat of steam is given and mass of water is given. So that will be equal to 3 into this amount. So Q4 will be equal to 676768000 joule. So the total heat required can be calculated by adding the 4 heats, that is Q1 plus Q2 plus Q3 plus Q4. If you add the total heat, it will be equal to 9.1 into 10 to the 6 joule.